Hey, what's up, you guys? I'm going to go ahead and show you the combination of SOHCAHTOA and Pythagorean Theorem style problem that we can use here. You're given a question that gives you a statement, and you want to create triangle ABC that makes the statement true. So the statement is sine of A is equal to 7 over 25. So I need to create a triangle where this is a true statement, and I want to know all three sides of the triangle. So here's a triangle. I'm going to go ahead and put in a right angle right here. It looks like where it would be. And all these triangles that we'll be dealing with are going to be right triangles. So there are three steps to this procedure. We want to draw triangle ABC and label it from A's perspective. Make sure A is not the right angle. So what I'm going to do is I'm going to go ahead and label this A, B, C. When you are working with these types of problems, I would suggest that you just label the triangles exactly the same way that I do. Remember, when we label angles, we use capital letters, meaning uppercase. So A, B, C, big A, big B, big C. So now we want to label the triangle from angle A's perspective. So angle A is this angle right here. Go ahead and color it in. And I want to label all of the sides from its perspective. So this side would be the opposite side. And remember, across from the right angle is the hypotenuse. And then that leaves us with this side down here, which is the adjacent side. Okay. Now, step 2, once you're done with this, you can use this statement to find two lengths of the sides. So we're given sine, right? If you remember SOHCAHTOA, S-O-H, sine is the opposite side over the hypotenuse. So I know both the opposite side and the hypotenuse just from this statement, 7 over 25. The 7 on top is the opposite side, and the 25 on the bottom is the hypotenuse here. So I know both of these sides. I know the opposite and I know the hypotenuse. What I don't know is this adjacent side, this side down here. So the last thing that I want to do is use the Pythagorean theorem to find the missing side. So this is the side we don't know. If I remember Pythagorean theorem, we have a squared plus b squared equals c squared. So we'll call this one b. How do I know that this one's b? Well, it's the bottom. B stands for bottom. And c is the hypotenuse. So one way you can remember it too, I'm just going to write this out, is you could do the opposite side squared plus the adjacent side. This is the exact same thing as Pythagorean theorem. I'm just calling it, instead of A, B, and C, I'm just calling it opposite, adjacent, and hypotenuse. This works too. I wanted to show you this because it's kind of a nice translation of it. So 7 to the power 2 plus, we don't know the adjacent side, I'll call it B for bottom, and then the hypotenuse is 25. I'll square that. And from here, you're just doing Pythagorean theorem things, right? 7 squared is 49. We can't put b squared into our calculator, so I will just leave it as b squared. And then 25 in our calculator. Well, I'm going to have to actually, let's go ahead and open up Desmos. Let's do 25 squared. 125. Okay. So now I need to get the b squared by itself. So I'm going to subtract 49, and whatever I do on one side of the triangle, I have to, or one side of the equation, I have to do on the other. It's going to give me b to the power 2 on the left because we wanted to get it alone. And 625 minus 49 is 576. This is 576. Okay, the last thing that I need to do here is take the square root of both sides because I have b squared and I don't want b squared, I just want b. So I need to turn it into b, and then let's go ahead and take this back over to Desmos. Let's do the square root, which is here, of 576, and that's equal to 24. So that is this missing side here. Remember, the answer that we want is we want the triangle. So I'm going to go ahead and erase this. I'm going to put 24. And there's our triangle, right?